Today we're diving deep, way beneath the Earth's crust, to get a handle on one of the most powerful forces on our planet, volcanoes. And believe me, there's so much more than just mountains that occasionally explode. They are the architects of the very ground we walk on. So let me just start with this question. What single force out there has the raw power to build a mountain from absolutely nothing, forge a brand new island out of the sea, and, at the exact same time, hold the power for both incredible creation and total destruction? Yep, you guessed it, volcanoes. These geological giants are behind some of the most dramatic landscapes you will ever see. But here's the thing. To really understand how they shape our world on the surface, we've got to start where their story begins. Deep, deep beneath our feet. Right, so if you really want to understand a volcano, our journey has to start in the hidden world of magma, long before it ever gets a chance to see the light of day. This is where we run into something geologists call intrusive landforms. And you know what? The name is actually perfect. Magma intrudes into the rock of the Earth's crust, but instead of erupting, it just cools down and hardens, creating these amazing structures that can stay buried for millions of years. Check this out. This image gives us a fantastic blueprint of that whole underground world. Notice how the magma isn't just one big blob. It's pushing its way through cracks and between layers, creating this whole complex network. You can almost think of it as the plumbing system for a volcano, hidden way down below. Now, the biggest of these hidden structures, they're called batholiths. Try to picture a massive, dome-shaped body of magma, sometimes covering thousands of square kilometers, that slowly cooled deep inside the crust. These are basically the cooled-down foundations of ancient magma chambers, and they often form super hard rock like granite. And then you've got these things called laccoliths. Now, unlike those huge batholiths, these form when magma forces its way up and pushes the layers of rock above it into this distinct mushroom or dome shape. It's just an incredible example of the sheer pressure building up from below, strong enough to literally bend solid rock. But you know, as fascinating as this hidden world is, things get truly spectacular when that magma finally breaks on through to the surface. And this is where we get what are called extrusive landforms. Simply put, these are the volcanoes we can actually see, the mountains built up layer by painful layer from all the lava and ash that erupts onto the surface. And as you can see from this gallery, volcanoes are not a one-size-fits-all kind of deal. They come in all sorts of shapes and sizes. And what determines their final form, whether it's a gentle slope or a steep, scary-looking cone, is all about the type of lava that creates them. So this table here breaks down the key differences. We've basically got three main types. You have shield volcanoes, built from really fluid, runny lava, which is why they get so wide. Then there are composite volcanoes, built from alternating layers of thick lava and ash, which lets them grow super tall and steep. And finally, cinder cones, which are the simplest of the bunch, just formed from loose particles shooting out of a vent. So let's take a closer look at the gentle giants, shield volcanoes. Their lava is super fluid, almost like basalt, so it just flows for incredible distances. This creates these volcanoes with a low, wide profile, kind of like a warrior's shield lying on the ground. And fun fact, these are actually the largest volcanoes on Earth. Next up, the towering peaks, composite volcanoes. These are your classic, picture-perfect, cone-shaped volcanoes. They're built from much more viscous, which is just a fancy word for thick and sticky lava, that doesn't flow very far. This gets mixed with layers of ash from more explosive eruptions, allowing them to grow into the highest volcanoes on the entire planet. And finally, we have the simple sprayers, cinder cones. These are typically a lot smaller. They form when loose volcanic bits, like ash and cinder, get shot out from a single vent and just pile up around it, creating a steep, cone-like hill. Pretty straightforward. Okay, now that we've met the different types, let's zoom out for a second. Where on Earth do we actually find these fiery mountains? Is there any kind of pattern? Oh yeah, there is definitely a pattern. Get this. An absolutely incredible 95% of the world's active volcanoes are not just scattered randomly. They are concentrated in very specific zones, the boundaries where the Earth's massive tectonic plates are grinding against each other. And this map just lays it all out perfectly. You can literally trace the edges of the tectonic plates by playing connect the dots with all the volcanoes. The most famous of these, of course, is the Circum-Pacific Belt, which you probably know as the Ring of Fire. It circles the Pacific Ocean and is home to most of the world's most powerful and dangerous volcanoes. So all of this intense power concentrated right along these plate boundaries has a direct and profound impact on life. And this is where it gets really interesting, because volcanoes are a true paradox. They represent both immense destruction and, surprisingly, incredible creation. First, let's not sugarcoat it, the destructive side. Eruptions can be absolutely catastrophic. You've got fast-moving lava flows that bury everything in their path. The ash and poisonous gases create serious health hazards and can even lead to acid rain. And on a bigger scale, they can trigger devastating mud flows, tsunamis, and even mess with the global climate for years. But then, there's the other side of the coin, the unexpected gifts. Over time, that very same destructive lava breaks down into unbelievably fertile soils, which are perfect for farming. Volcanic activity is responsible for creating precious stones, and the volcanic rocks themselves are like a treasure chest of valuable metals and minerals. And speaking of unexpected gifts, one of the most spectacular results of all this underground heat has got to be geysers and hot springs. These amazing phenomena are a direct result of the very same geothermal energy that powers volcanoes. So what is a geyser really? Well, think of it like a natural fountain of superheated water and steam that just erupts from the ground. It happens when water seeps deep into the earth in these volcanic areas and gets heated by magma way past its normal boiling point. It's an incredible display of power, and what's really wild is that almost all of the world's geysers are found in just 3 places: Iceland, New Zealand, and Yellowstone National Park here in the US. And this really brings us all the way back to our main idea. Volcanoes are a force of profound duality. They are creators and destroyers, builders and demolishers, all at once. So it leaves us with one last thought to chew on. When the ground starts to tremble, should we see it only as a threat? Or maybe, just maybe, also as the promise of a world that is constantly and powerfully renewing itself?